Alright, let's start doing some random problems. Is there a filter to say to not do a problem that we have already done? Status, yeah. Let's do to do. So we'll do only problems that we have never done. And let's pick random problem number 1. Alright, minimum positive subarray. You are given an integer array and two integers L and R. Your task is to find the minimum sum of a subarray whose size is between L and R and whose sum is greater than 0. Return the minimum sum of such a subarray. If no such subarray exists, return -1. A subarray is a contiguous non-empty sequence. Alright, whatever. So we are given this array. L is 2 and R is 3, which is 2 integers. Your task is to find the minimum sum of subarray whose size is between L and R. Okay, size is between L, whether L inclusive or not, I don't know. Um, 3 and -2 is a subarray of size 2 whose sum is 1. 1 and 4 is again a subarray of size 2 whose sum is 5. 3 minus 2 1 is a sum of size 2 and whatever. Minimum sum of such a subarray. Also to find the minimum sum of a subarray whose size is between L and R and whose sum is greater than 0. Minimum sum निकालना उसका. Okay, out of these subarrays 3 minus 2 has a sum of 1. 3 minus 2 sum of 1, which is the smallest positive sum, hence the answer is 1. Okay, I mean, one option is we can consider all the subarrays of all the sizes, like of subarray of size L, subarrays of size L plus 1, subarrays of size L plus 2 till subarrays of size R, using window, and then whichever is the largest, because that's the only way we can do it, right? Because can we do both together, like L, I take a window of size L. Now I guess first I increase it till R, consider all of them, and then I decrease it and then increase it and decrease it then increase it. Oh, it could be like that. So मैं एक window ली of size 2, I consider it, then I increase, okay, it to size 3 3 2 minus 1. Now I decrease the size again back to 2. I'm able to consider all cases, is the only problem. So let's say L equals to 2 and R equals to 5. Right, so I do A, B, then I do C, then I do D, then I do E. Now size 5. Now I can remove, with A I've considered all sizes, right, from 2 to 5, so A is done. Now with B I am considering size 4. How will I consider with B? How will I consider the size of 2? So what I'm saying is how many ever L and R are, that many number of iterations I will need to my time composite will be R minus L times N. Can I do it in O of N is the only question that I don't have a good answer for. तो अगर मैंने ये किया बी सी डी ई, let's say, so I have considered A B C D E, and now I shrink the window, so I shrink it like this. I could further shrink it, but if I shrink it further, then I have not considered all combinations starting with B, right? I want to consider all combinations starting with A, so which was AB, which was ABC, ABCD, and ABCDE. Now I want all combinations starting with B. That would mean BCDE is 1. Yeah, nahi ho raha hai, so I think you just consider one window size, and then you do the same for all window sizes, right? Okay, so window sizes is the thing. Integer dot I forgot what is it called in Java. What is max? I forgot. I'm gonna have to search now. Max integer. Is it? Does it compile? It won't. It's not. It's called something else. I forgot what it's called. I can take some large value. Okay. Come on. Max one value. Okay. This is fine now. Window size equals to L. Window size is less than equals to R. Window size plus plus. For each window size, just solve with this window size, and you will get which is fine like this, and then you return min sum. This is good enough, I guess. And now solve list of integer nums window size. whatever it says, if no such subarray exists, return -1. That's what we are doing here. Now if the window size itself is greater than the length of nums, you have to return this. Otherwise you first get the sum till the window size. So so now I have this first window and a sum of that first window. Oh, my system is so slow. If sum is greater than 0, then min sum equals to sum, otherwise not. So you have built it till this window size. Now what you want to do is you have to shift right. Okay, इस पोजीशन में calculate the size, I guess. इस पोजीशन में, so you want to do one more because you do -1, I guess. So now you will calculate the next window, if there is a next window possible, which if there is, then what you would do is Okay, think we are close to being done. Your time complexity is r minus l times n. Space complexity is 0 over 1, and you are not able to solve it. Line number 16. List has size, not length. Okay, let's run again. Min sum is camel case. Run again. Alright, submit. We are done with the first problem. I wanna go back to the problem list, I guess. How do I go back and pick another problem? Just this one, I guess. Pick one. Okay, let's do another problem. Right, problem number 2. This is problem number 2. Count asterisks. You are given a string S where every two consecutive vertical bars are grouped into a pair. Let's remove some things. Okay, you're given a string S where every two consecutive vertical bars are grouped into a pair. In other words, the first and second pipe make a pair, third and fourth pipe make a pair, and so forth. Return the number of asterisks in S, excluding the asterisk between each pair of pipe. Know that each pipe will belong to exactly one pair. Let's look at this example. So it has Leetcode, some asterisks, and some pipes. The considered characters are underlined, so whatever. The first and the second pipe. What is saying? You are given a string S where every two consecutive vertical bars are grouped into a pair. So okay, this is grouped into a pair, this is grouped into a pair, this is grouped into a pair. In other words, the first and second pipe make a pair. हाँ ठीक है. It is the number of asterisk in S, excluding the asterisk between each pair of pipe. Okay. So in this pipe, you want to consider the characters between the first and the second pipe are excluded from the answer. But also the characters between the third and the fourth pipe. First, second. Okay. First, second is one pair. Second, third don't form a pair. Got it. First and second form a pair. You have to go through everything. Each pipe belong to exactly one pair. Return number. ऐसा कुछ, is it a given thing that there are, for example, there are 1, 2, 3, 4 pipes. Can we say the number of pipes are even or not? Can that be guaranteed? Even number of vertical bars, yes, that is guaranteed. Then it's easy, because what that means is after pipe number 1 you don't have to consider, after pipe number 2 you can consider, after pipe number 3. I think it's a simple thing. If the pipe number is 1, because जब तक कि मुझे कोई भी पाइप नहीं मिला है तब तक तो I will consider asterisks. So if the pipe number is 1, that means I know there is another pipe, so I don't have to consider. So pipe number 1 don't consider, then pipe number 3 don't consider. Okay, pipe number 2 you can consider. I get it, right? It's simple. You just maintain the pipe number. Okay. For each char C in a star 2 char array, let me mute my phone. For each char C in a star 2 char array, if C equals to pipe, then current pipe plus plus, and if C equals to star, then you count it only if current pipe is E1. Current pipe percentile 2 equals to 0. Then you do count plus plus. You should maintain a count. And do count. Alrighty, let's run. Yeah. I'm confident to submit, and I'll probably be proven wrong. But it worked. Alright, done with 2 problems. Let's go to 3rd problem. Pick another random problem. This is problem number 3. We are given 2 arrays of integers, fruits and baskets, each of length n, where fruits represent the quantity of the ith type of fruit and baskets represent the capacity of the zth basket. From left to right, place the fruits according to these rules. Okay, so there are 2 array of integers. One is fruits, another is baskets. दोनों की length n है. Where fruits of I represents the quantity of the ith type of fruit and baskets represents the capacity of the jth basket given. From left to right, place the fruits according to these rules. Each fruit type must be placed in the leftmost available basket with a capacity greater than or equal to the quantity of that fruit type. Each basket can hold only one type of fruit. If a fruit cannot be placed in any basket, it remains unplaced. Return the number of fruit types that remain unplaced after all possible allocations are made. Okay, let's read it again as long as it's not fully clear. Fruits have, baskets have, fruits and baskets represent the quantity of the ith type of fruit. Baskets represent the capacity of the jth basket. Each fruit type must be placed in the leftmost available basket with a capacity greater than or equal to the quantity of that fruit type. Makes sense to me. Each basket can hold only one type of fruit. That is also, yeah, I think I got all of it. Let's look at the example. If a fruit cannot be placed in any basket, it remains unplaced. Remember the number of types that can remain unplaced after all possible allocations are made. यहाँ पे देखते हैं क्या है. So there are 3 fruit types. 3 fruits of 0 is 4. So it will be placed in basket number 1 because it can't be placed in basket number 0. Fruits of 1 is 2. It is placed in basket of 0. Fruits of 2 is 5. It cannot be placed in the last basket, so you don't place it. So you have to go left and right from in fruit category, is it? Seems like. So the answer is 1. One fruit type wasn't placed. Okay. 3, 6 and 1. First look at fruit number 0. 3, you can place it in the first basket. Fruits of 1, 6, you can place it in the third basket. Fruits of 2 is 1. You can place it in the basket, middle basket. I guess I'm getting it. It's not that hard. So you have to start with fruits. That is clear. So you have to go fruits via fruits. That is the left to right. So for int equals to 0 is less than fruits dot length is plus int so you need this capacity. We have to see which is the basket we will place it. Again, in the basket also we'll place it left to right. What is a basket capacity? Can basket capacity be negative? Both have to be at least 1. Okay. I mean, I'm not liking it because it's becoming sort of n square-ish. Can I do better than n square? I don't know, but I can definitely do it in n square. I think there is no other way, right? You have to, for every y, you have to go j equals to 0, j is less than basket start length. Only thing is you could put it in a linked list and keep reducing the size, but the time complexity doesn't change. If baskets of j, if the capacity is greater than or equals to needed capacity, then you're gonna break. You have not, so you say, yeah, I found somebody, yeah. So I have placed it and this basket is no longer available, so make it something not available and break. And if it wasn't placed, then the count of unplaced will be increased. And this is the solution. That's it. Right, run the code. And submit it. Alrighty. Let us move to the next problem. This is problem number 4. Is it an easy one? It's looking some complicated shit. Image smoother is a filter of size 3 cross 3 that can be applied to each cell of an image by rounding down the average of the cell and the 8 surrounding cells. By rounding down the average of the cell and the 8 surrounding cells. It is the average of the 9 cells in the blue smooth corner. If one or more of the surrounding cells of a cell is not present, we do not consider in the average. That is the average of the 4 cells in the red smoother. Okay, smooth it out, bro. Given an m cross n integer matrix representing the grayscale of an image, return the image after applying the smoother on each cell of it. Okay, how are you smoothing it? How did it become 0? 111, 101. explanation for the points 0 0 0 2. Okay, for the points um, 0 0 0 1 0 2 0 2 2 0 and 2 2, its sum is coming out as 3 and 4 cells. Yeah, for 0 1 1 0 1 2 and 2 1, there are 6 cells that you're able to get. Is it 0 1 0 1? Okay, yeah, you're getting 6 cells, correct. Okay, I got it. Yeah, just apply the smoothing, I guess. But is there a, like, for every, okay, it's 8, no, doesn't matter, 8 times n square. You can do some optimization, but it's still 8 times n square, so it's not like um, you're doing something magical. But okay, let's think about it. When you shift one cell, you subtract this and you add this. Okay, just do the smoothing, simple smoothing. Yeah, nothing fancy. Okay, let's do this smoothing. Okay, so int okay, so I want to get these 9 numbers. You know the 9 numbers that I'm talking about exactly. So let's do mn for int row equals to m minus 1, and row is less than equals to m plus 1 row plus plus. So the 3 rows that we are looking at. For int column equals to n minus 1, column is less than equals to n plus 1, column plus plus. if row is greater than equals to 0 and row is less than start length, then you do okay. But that's not it, right? There are more things. You have to look at both row and column. Okay, so now I have this sum. I have to do floor. By default it's floor, so that's not a problem. You do sum by count. Okay, in integer, when you do integer division, it is a floor. So this is it. Run it. Alrighty, submit it. And it's worked. Let's go and do the next problem. Okay, it's giving us some premium problem. Let's look at some other one. Range sum of BST. This is your problem number 5. Given the root node of a binary search tree and two integers low and high, return the sum of values of all nodes with the value in the inclusive range be low high. So this is the BST. We can say it's a BST. We have to find what exactly? Sum of values of all nodes with the value in the inclusive range. Yeah, just traverse the tree and see if they're in this range. But given that you're given the range, you wouldn't want to go beyond that, I guess. So the range here, for example, is 7 and 15. So, but you can only start from 10. Is 10 between 7 and 15? The answer is yes. So you count it. And would you want to go on both left and right sides? Again, the answer is yes. So you go to 5. 5 is greater than 7. That means there is no point. Sorry, 5 is less than 7. So there is no point in going to the left of 5. So you would go to the right. So you have to be that smart about traverse. I mean, you can always just traverse all the nodes and then say whether you follow or not. But the right thing to do is, if you had a node which is greater than the low value, you won't go to its left. If you're at a node which is